going to take a look at lesson 4.3 today, right triangle trigonometry. We're going to look at the 6 trig functions. You guys are very familiar with these, so it's not going to be anything we haven't done yet. Just a quick reminder. Let's start by the concept that we're going to be dealing with right triangle trigonometry first. Anytime we have a 90-degree or right triangle, we always refer to the opposite side of the 90 degrees. That's our longest side as the hypotenuse. And if we define the one angle, theta, it could be either of the other two. The side adjacent we refer to as adjacent. The side opposite, of course, we refer to as opposite. Using the lengths of the 3 sides, you can form the 6 ratios that define the 6 trig functions of an acute angle, acute, less than 90, in the following way. We have sine, cosine, tangent, cosecant, secant, and cotangent. We're going to be getting into quite in-depth study of these 6 ratios. It's important. In the middle of page 273, it says that theta lies between 0 and 90 for this section. 0 to 90 degrees. When you first began your study of the 6 trig functions, I think you, I don't know if everybody did this, but SOHCAHTOA. So, sine, S-O, indicating sine is the relationship opposite O over hypotenuse. Ca, C-A-H, C-A-H, cosine is defined as the adjacent over the opposite. And tangent, TOA, TOA, is opposite over adjacent. What's even more fascinating as we delve more deeply into this, if we look at cosecant, and we see its definition of hypotenuse over opposite, we see that to be the direct inverse of sine. So sine and cosecant are inverses of each other. Likewise, the cosine and the secant is defined as opposite over adjacent. We can see that is the reciprocal of cosine, adjacent over opposite. And then tangent, cotangent. Those two make sense. Whoops, cotangent. Cotangent, tangent. So that's going to be the adjacent over the opposite. Again, just the reciprocal. And the way that I remember sine and cosecant to be related is because it's SC and it's CS. I always thought sine and secant should go together because they both start with S, but it's just the opposite. So our sine and cosecant, our cosine and secant are reciprocals, and tangent and cotangent. So example 1 says we're going to be evaluating trig functions, and one of the things that I've always thought was it's important for us to look at directions and study what it is they're asking us to do. We're going to look at all the trig functions for this particular case right here and define those. So given this right triangle, we have a 3 and a 4, and by the Pythagorean theorem, we know that hypotenuse squared is equal to a squared plus b squared, or opposite squared plus adjacent squared. So if we have our angle theta right here, opposite squared, the opposite side of that angle would be 4 to the 2nd power, and the adjacent side, the side next to the angle, would be 3 squared. So we know that we can solve for our hypotenuse by looking at 16 plus 9, the hypotenuse squared, 25. The hypotenuse value, the square root of that, or 5. So in example 1 it says the 6 trig functions of theta are therefore very simple for us. The sine, so katoa, opposite over hypotenuse. The sine of theta, opposite over hypotenuse, is simply defined as 4/5. The cosine, adjacent over hypotenuse, would be 3/5. And the tangent, opposite over adjacent, tangent of theta, 4/3. And knowing that sine and cosecant are reciprocals, we can simply jump right into our solution. Cosecant of theta is just the reciprocal of the sine, 5/4. The secant is the reciprocal of cosine, that would give us 5/3. And the cotangent being the reciprocal of tangent, not that, 3/4. Problem number 9 is that first problem they want you to do after example 1. And the directions say find the exact values of the 6 trig functions of the angle theta shown. Problem 9 has theta in that lower left. We have an adjacent side of 15 and an opposite side of 8. Well, we know that 15 squared plus 8 squared, 225, check my math, plus 64. That gives us a sum of 289. If we take the square root of that, we see that our hypotenuse has a value 17 units. 17 units. So now, in defining the exact value, sine, remembering sine, opposite over hypotenuse, this would be our exact value for the sine. Cosine, you guys know to be adjacent, 15 over hypotenuse, 17, and the tangent, opposite over adjacent, 8/15. Now, quick and easy, cosecant, we're just going to take the reciprocal, 17/8, secant, reciprocal of cosine, 17/15, and cotangent, 15/8. Example 2 gets right into evaluating trig functions of a 45-degree angle, the sine, cosine, and tangent. We've constructed our right triangle, as they asked us to. We're going to choose 1 as the length of the adjacent side. So if this were our value, theta, the adjacent side being 1, from geometry, we're going to remember that these two angles opened up to create congruent sides. Those two angles are creating congruent sides. So we know if the adjacent side is 1, the opposite side is also 1. Using the Pythagorean theorem, 1 squared plus 1 squared is equal to 2, which is equal to the hypotenuse squared. Hypotenuse squared equals 2. Therefore, the hypotenuse is equal to the square root of 2. Now we can quickly and easily find the 6, or the 3 trig functions. In this case, they're asking us for an example 2, and these are the values that are going to come in handy and help us to remember our unit circle. So the sine of 45 is opposite over hypotenuse, 1 over the square root of 2. We cannot have a radical in our denominator, so we multiply top and bottom by the square root of 2, yielding square root of 2 over 2. You go back to your 45, your unit circle. Sine, we know to be the y value, and if you look at your unit circle, you will see at 45 degrees, your y value is the square root of 2 over 2. Well, very similarly, cosine, which is going to be exactly the same, is 1 over the square root of 2. Simplifying that, we get square root of 2 over 2. And so we know our x value, the unit circle, at 45 degrees. Square root of 2 over 2 is our y. Square root of 2 over 2 is our x coordinate. And that's how we find the location on the unit circle when our central angle is 45 degrees. Please try problem number 21. Take a look at that and come right back here and we'll go over the solution. So in problem 21 it says construct an appropriate triangle to complete this table. We want our measure theta to be between 0 and 90. We are given a 30-degree angle in problem 21, which means theta is between 0 and pi halves, degrees and radians. So we can see both of those. The sine of 30 degrees, we're asked to complete the table. So in radians, we take 30 degrees, and converting to radians, we take our unit conversion factor. Pi is to 180. We're going to multiply those. 30 over 180 is 1 over 6. So pi over 6 should be our solution for radians. And then it's asking us to find the function value. So a 30, 60, 90, let's talk about the relationship here. We know that the 30 degrees is the smallest in the triangle, and it has the smallest value for its opposite side. 60 is the next biggest, and we should remember that our values are 1, square root of 3, and 2 in ascending order as far as their value. So the second largest side should be the square root of 3. The largest side, being the hypotenuse, should be 2. Now if we look at finding the function value, the sine of 30 degrees, we know that that's opposite over hypotenuse. Opposite over hypotenuse would give us 1 over 2. The sine of 30 is 1 over 2. That's the second part of your table.